The mysterious interstellar object known as 3I/Atlas has once again captured the attention of astronomers and the public alike after re-emerging from behind the Sun, offering scientists a fresh glimpse at this rare and intriguing visitor from deep space. Its reappearance marks a crucial moment for observational astronomers, who have been eagerly awaiting the opportunity to gather new data after the object disappeared temporarily into the Sun's glare during its perihelion. Now that it has resurfaced, researchers are gaining clearer insights into its physical state and the path it is taking as it continues its highly eccentric journey through our solar system. The object is widely believed by experts to be a comet composed primarily of carbon dioxide ice, a fairly unusual makeup compared with the more common water ice comets typically observed. This chemical composition already makes it scientifically valuable, but its interstellar origin elevates its significance even further, offering clues about the types of objects that might be wandering between star systems. As it speeds along its elongated trajectory, 3I/Atlas is expected to make its closest pass to Earth just a few days before Christmas, continuing its outward escape from the solar system after swinging around the Sun. This timing has added a layer of excitement, as the holiday season may coincide with a surge in both scientific findings and public fascination. Perhaps even more interesting is the fact that the object appears to have survived its closest approach to the Sun largely intact. Many astronomers, including Harvard's well-known astrophysicist Avi Loeb, had speculated that the extreme heat and intense gravitational forces at perihelion might cause the object to fragment or disintegrate entirely. In one of his earlier blog posts, Loeb predicted that 3I/Atlas might break apart, similar to how Comet Ison infamously dissolved after passing too close to the Sun nearly a decade ago. However, new observations suggest otherwise. Fresh images captured by the Nordic Optical Telescope in the Canary Islands have revealed that 3I/Atlas remains a single, coherent body, showing no sign of fragmentation or catastrophic breakup. Loeb himself acknowledged this in a follow-up statement, conceding that the object did in fact weather the perihelion without falling apart. These latest images also display a distinct feature known as an anti-tail, a curious appendage seen pointing toward the Sun rather than away from it, contrary to the direction in which traditional cometary tails typically flow. The anti-tail is believed to be composed of heavier dust particles that resist solar radiation pressure and therefore do not get pushed outward in the same manner as lighter particles. Their unusual trajectory causes the tail to appear sunward, creating a visually striking phenomenon. Yet despite the conventional explanation involving dust jets and solar radiation, Avi Loeb continues to entertain a far more unconventional idea, that these jets might instead represent thrusters on a technological spacecraft. In an interview with NBC News, Loeb suggested that if 3I/Atlas is not merely a natural object, but a craft originating from an advanced extraterrestrial civilization, then the Sun-facing jets could be serving a purpose, perhaps boosting the object's acceleration away from the Sun. Such a maneuver, according to Loeb, could make sense for a spacecraft attempting to maximize its velocity rather than relying on the Sun's gravitational assist to slow or alter its path. He proposed that exhaust thrust directed toward the Sun would effectively propel the object in the opposite direction, speeding up its departure from the solar system. This idea forms just one part of a broader list of anomalies Loeb has collected in support of his hypothesis that 3I/Atlas may be an engineered spacecraft rather than a natural comet. He previously studied the anti-tail phenomenon in depth, noting its prominence in Hubble Space Telescope images from August. As more images have emerged over the months, the appendage has grown longer, leading Loeb to believe that natural explanations may be insufficient. However, most scientists remain unconvinced. The astrophysical community largely views 3I/Atlas as a typical interstellar comet exhibiting familiar behaviors, and Loeb's speculations have been met with substantial skepticism. Among the critics is Jason Wright, an astronomer at Pennsylvania State University, who argued against Loeb's interpretation in a September 29 blog post. Wright pointed out that anti-tails are not exceptional features. Similar sun-facing enhancements have been documented in the past, particularly in cases where large dust grains were ejected and remained relatively unaffected by the solar wind. To further support his point, Wright referenced a 1974 study describing the peculiar anti-tail of Comet Kohoutek, which displayed comparable characteristics despite being entirely natural. According to Wright and many other astronomers, the behavior of 3I/Atlas is not unprecedented and falls well within the realm of ordinary cometary physics. Nonetheless, Avi Loeb remains steadfast in his belief that alternative possibilities should not be dismissed. He argues that maintaining scientific curiosity means remaining open to unexpected explanations, even if they challenge conventional assumptions. In one of his recent blog posts, he outlined new calculations suggesting that 3I/Atlas may be significantly larger than initially estimated. Based on the mass it appears to be shedding, Loeb calculated that the object could possess a surface area equivalent to that of a sphere more than 14 miles in diameter, a remarkable size that would place it among the most massive comet-like objects ever observed. If true, this would further distinguish 3I/Atlas from typical solar system comets and potentially hint at something extraordinary. Loeb also argued that if the jets were technological rather than natural, they might be utilizing advanced propulsion systems capable of achieving far greater exhaust velocities than anything produced by chemical or even nuclear thrusters developed by human civilization. Higher exhaust speeds would drastically reduce the amount of mass required as propellant, meaning the object could execute maneuvers without sacrificing large portions of its structure. According to Loeb, this could reconcile the observed mass loss with his theory of an extraterrestrial spacecraft, suggesting that the required fuel might represent only a small fraction of a craft's total mass. Despite the bold nature of his ideas, Loeb insists that he is not claiming certainty, but merely advocating for scientific humility and exploration. To him, acknowledging all possibilities, even improbable ones, forms the foundation of true science. He has repeatedly emphasized the importance of gathering more data and awaiting additional observations before drawing firm conclusions. In his view, the coming weeks will be critical as 3I/Atlas continues to move away from the Sun and becomes more easily observable from Earth-based telescopes. With clearer images and more precise measurements, astronomers will soon be able to determine whether the object behaves strictly like a natural comet or if it exhibits behaviors inconsistent with natural explanations. Loeb humorously remarked that if 3I/Atlas were indeed an alien mothership, humanity could only hope it is not bringing any unpleasant surprises during its holiday season approach. Although this comment was made partly in jest, it also highlights the broader cultural fascination with the unknown and the growing public interest in the possibility of extraterrestrial intelligence. Even if 3I/Atlas turns out to be an entirely natural object, the lively scientific debate surrounding it has already sparked widespread curiosity and revived discussions about humanity's place in the universe. Ultimately, whether 3I/Atlas is a conventional interstellar comet or something far more exotic, its journey through our solar system serves as a rare and invaluable opportunity for scientific discovery. Only a handful of interstellar objects have ever been observed passing through our cosmic neighborhood, including the mysterious Oumuamua and the Comet 2I/Borisov. Each of these objects offers a unique window into the processes shaping other star systems, revealing information that cannot be obtained through telescopic observations alone. As astronomers continue monitoring 3I/Atlas, they hope to uncover clues not only about its nature, but also about the conditions and materials that exist beyond our Sun's gravitational reach. In the end, the story of 3I/Atlas is a reminder of how vast our universe truly is and how little we still understand about its countless visitors. Whether natural or technological, icy comet or alien craft, the object invites us to look upward with wonder, to question our assumptions, and to keep exploring. And as scientists around the world gather new data in the weeks ahead, the mystery may finally begin to unravel, offering answers that could reshape our understanding of interstellar phenomena or perhaps reaffirm the extraordinary beauty of natural celestial mechanics. In either case, the renewed observations of 3I/Atlas promise to expand our knowledge, ignite our imaginations, and keep the spirit of discovery alive as it races away into the vast darkness of space.